yeah, what is a friction? Friction is something which opposes the motion of any object or any other surface, or which opposes any impending motion or in the state of verge of motion, correct?
Yes, ma'am.
So if you see like an object is at rest, even though you are not applying any force, but if it is at rest means there is friction which is acting. Okay, like we experience the friction only when we apply force, but it doesn't mean that it is not existing. It exists. Okay, and it is a self-sustained force. Have I used that word? Did I tell you what that meant to be? Okay, so now I think I had told you the friction can broadly classified as static friction and kinetic friction, correct? Yeah. Static friction, and like the static friction nature itself is slightly different from kinetic friction. So static friction and kinetic friction. Okay, so what is a static friction? The frictional force which you see when the object is at rest relative to some surface.
Yes.
And obviously we should know that the friction comes into play when there is some two objects in contact, right?
Yes.
If they are not in contact, you don't see any kind of like frictional force. Okay, so that's why we have to use the word like relative to some surface. Okay, and they are in contact. That is must necessary. Like object at rest, and kinetic friction is one when the object is in motion. Yeah. Okay. So when it comes to static friction, okay, so if I just tell you, or if I just recall it to you, so let us say there is a surface and there is some object has been kept, and let us say we have applied some external force. Let me use the notation capital F for that. We know that initially I don't see the object is moving, but as we keep on increasing the applied force, at some point, okay, at some point, the object is just to start to move. Okay, so till it start to move, whatever the friction that exists, like opposite, and it will be represented where? It will be represented as the tangential or parallel to the surface between the two objects that are in contact, right?
Yes, sir.
So that is your Fs. And your Fs is not a constant force. It adjusts itself to the applied force, correct?
Yes.
How much force you apply, correspondingly, the static frictional force will also increase up to a limit. It can increase up to a limit. Okay, it can increase up to a limit, and that maximum value is there, no? That is called as Fs max. Okay, the maximum value of static friction. This is very important for us. Okay, that is Fs max. Like if the applied force slightly increases than Fs max also, the object will start moving. Okay, so that is our limit. Okay.
Yes, sir.
And this Fs max is independent of the area with which it is in contact. Like maybe the object is this big, or maybe the object is this big. Like area of contact is more. So it does not depend on the area of contact, but it, 1 minute. Yeah. So it just depends on which two surfaces are in contact. Okay. Which two surfaces are in contact, but it does not depend on area in contact. Okay, and it varies. It is found that it's an experimentally found one. So Fs max is found to be directly proportional to the normal reaction or normal force. So what is this normal reaction? I think I have told you in some class. What is this normal reaction? Do you remember? Have I told you? Like if
Yeah, you have told, but I don't remember really.
like it's a part of contact force, right? That's how we look in the chapter of NLM. So let us say there is an object kept on some surface.
Like you tell the
Okay.
table exerts some force.
Correct, exactly. Like there is some contact force. It acts at certain angle with the surface. Okay. So now how we have defined our force, like the component of the force along the surface, we called it as friction, and normal to it as normal reaction. This is one way you can imagine. Okay, so yeah, there is some. Okay, what shall I write for this? Contact force only, no? So I'll write whenever some two objects are in contact with each other, there will be some contact forces. Okay, got it. Now this contact force can be seen as having two components. The component along the surface, we call it as friction. The component which is perpendicular to the surface, we call it as normal reaction. Okay, this is one way to look. Or in the same way, just to get what is this normal reaction, we can imagine like this. Like, I know there is some downward force acting due to gravity and because of its mass, correct? But we never see the object, passing through the surface. We just see like it is at rest on the surface, correct? It is not going into the surface and, because of this force. That means there must be some, upward force which balances your mg, correct?
Yes, ma'am.
So that is what is your normal reaction. Okay. Yeah. So the reaction offered by the surface which is in contact with the body is what is our normal reaction here. Okay. Got it?
Yes, ma'am.
Yeah. So your Fs max is directly proportional to normal reaction. So whenever we have proportionality, what we will do? In order to put it in equality form, we introduce some constant. Here we write it as mu suffix s into n, where this mu s is called as coefficient of static friction. So what do you call this? Coefficient of static friction.
Static friction.
Yeah.
And N is Newton there?
No, n is normal reaction.
Okay.
Okay. So mu s is coefficient of static friction. Okay.
Yes.
So now this is the maximum limit. So under the static condition, what we can say, the maximum limiting force, okay, or the maximum limiting friction is always lesser than or equal to mu s into n. Can I say like this? Unless the applied force is less than our Fs max, the object will be at rest. Less than or equal to. Okay?
Yes.
Yeah. If the applied force exceeds this Fs max, the body will begin to slide.
Right. Oh.
Okay? And yeah, the point is, you can see like our Fs max, Fs is not fixed. Fs max is fixed for given to surface, but the frictional force is not fixed. It depends on how much external force you apply, right?
Yes.
How much external force you apply, and that's why we call it as self-adjusting force. Sorry, I think I said like self-sustained. I'm sorry, it is self-adjusting. Okay, self-adjusting force. Okay, self-sustaining means it's of different meaning. Sorry, it is self-adjusting means, you know, it sees, okay, how much is the applied force, corresponding to that some friction will be acted, but it is not that like you keep on increasing the applied force, your Fs will also is not going to keep on increasing. It can increase up to a maximum limit, and that is your, you know, the maximum limiting friction. That word will also be used. Fs max is nothing but maximum limiting friction. Okay, sorry, here I should not use the maximum word. When I write in the form of less than or equal, it is not maximum. It's like all the in between values, but the maximum value is mu s into n.
Okay.
The maximum limiting static friction is mu s into n. Okay. Yeah. So now when the applied force increases than your Fs max, the object will start moving, and in that case the friction that exists between the object that is sliding or rolling, we call it as kinetic friction. Kinetic friction.
So Ft.
Yeah. Okay. F suffix K. Okay. So, and in this case again the same rule. You know, I think the definition you can just write on your own. It's like when the applied force exceeds the maximum limiting friction, the object starts to slide, and once it starts sliding, then you cannot use the upper equation. You cannot use this above equation. In that case, whatever the frictional value that exists, so we call that as kinetic friction. And again, this kinetic friction found to proportional to the normal reaction, but in this case, the coefficient is called as, the coefficient of proportionality is called as, yeah, coefficient of kinetic friction. Yeah. Coefficient of kinetic friction. And there is one important thing is there. Always our static friction is greater than our kinetic friction, or you can say always mu s is found to be greater than mu k. This slight confusing fact, but it is true.
But kinetic friction is between moving.
See, it comes like this. Whenever, I mean, it is a fact and it is real that you require more force to start some object in motion than to keep it in motion. Okay, so that's the fact. Okay, you need more force because it was at rest for some long time. And there may be like, there are, you know, the surfaces are in contact. Here there may be some better electromagnetic bonds would have been formed. It is because of some bonds between the surfaces. I told you that this normal reaction or your friction is of electromagnetic origin. Do you remember? Or electrostatic origin, I can say. Yes, sir? But when the object starts to move, no, the bond forms are not so strong. When it is at rest, you know, the surface and like the surface atoms are there, no, they may form like quite well bonds, and you need to break it to bring them in motion. Okay, like some electrostatic bonds, some kind of attraction between the surface atoms. Okay.
Yes.
But when once it start to move, like it keeps on moving, like the surface and the, you know, the surface atoms on the two objects don't have much time to form a proper bond. Okay, so it is easy to now to keep them in motion. Okay.
Yes.
So that is why static friction coefficient is greater than kinetic friction. Or like once the object is moving, whatever the friction you see, that is slightly lesser than your maximum limiting friction. Okay.
Yes.
Is it clear?
Yes.
Yeah, and here also you can say, all these general laws can be said, like, Fk is proportional to n, and it is independent of the area that is in contact. Okay.
Yes.
Yeah. Then yeah, again, all these, whatever the equations we are giving in terms of friction, no, they are all empirical relation. Like, by performing experiment, they had been put forward. You do not have some standard, theories to predict it. Like maybe your gravitational or electrostatic force, all those laws can be somehow, evaluated. But here, like, you have only, like, do some several set of experiments and look into their data and put it in the equation form. That is what is your empirical relation. All your frictional laws are going to be empirical rules. Okay. Yeah. The next thing is your NCERT with you?
Yes, ma'am, I have.
Okay. Can you go to page number 101? That is completed now.
Yes.
Can you go to page number 102?
Yes, ma'am.
Yeah. So I'll just read. There is one point which, like, I want to bring it to your notice. So there's in the paragraph starting, like, thus when two bodies are in contact, each experience a contact force by other. Friction by definition is the component of the contact force parallel to the surface in contact, which opposes the impending or the actual relative motion between the two surfaces. Friction can be impending, like opposing force for impending motion, like the motion that is possible in future. Okay, so that's what is the meaning of impending motion. Or it's like actual motion, like your kinetic friction, okay, between the two surfaces. Note that it is not motion but the relative motion. That is very important. Okay, one object should move relative to the other surface. Is it clear?
Yes.
Yeah. Relative motion that the frictional force opposes. And then, yeah, that much is enough over there. So that I want you to underline, that is the component of the contact force which acts parallel to the surface. That is very important. Okay. Yeah. Yeah. There's one idea also given. I think I'll just read it out for you. Like, what forces causes the acceleration of the box? Okay, sorry, it starts from the 2 lines below. If the box is stationary relative to the train, it is in fact accelerating along with the train. Correct? Like there is some box is kept inside the train, but the train is moving. Correct? When I stand outside, I also see the box is also moving along with the train. Correct?
Yes.
Yeah. But if you are inside the train, what do you see? The box is at rest, like relative frame. Correct?
Yes.
Yeah. So now, but apparently from outside, like the box position is also changing with time, means it is accelerating. So where it is, yeah. If the box is stationary relative to the train, it is in fact accelerating along with the train. What force causes the acceleration of the box? Clearly, the only the conceivable force in the horizontal direction is the force of friction. If there were no friction, the floor of the train would slip by and the box would remain at its actual position due to inertia and hit back the side of the train. This impending relative motion is opposed by the static friction Fs. The static friction provides the same acceleration to the box as that of the train, keeping it stationary relative to the train. So what they are saying is, this idea is important, like maybe helpful for you to solve problems in future. So it's like, imagine this is a compartment of a train. Just a minute. Okay.
Yes, ma'am.
Let us say the train is accelerating in this way. And let us say our box is here. Okay. If the box was not moving along with the train, it has a tendency to hit back to this back wall. Do you agree?
Yes, ma'am.
Yes or no? Like if it has no tendency to accelerate along with the train, definitely it will be just at rest, and it is like, the train will move ahead, so it hits the wall. Correct?
Yes.
In other way, if you look, it has a tendency to move back relative to the surface of the train. Do you agree?
Yes, ma'am.
That means the friction should be opposing its future predicted motion, and that is what is accelerating this block. Okay.
Yes, ma'am.
It is just balanced. Your Fs is equals to m into a here, just balanced, so that it also accelerates along with the direction of the train. Because I in nature I'm not seeing any other force acting on this body along the horizontal direction, but I could see, like, along with the train the box is also carried away. That we are seeing, but I don't see any force who is causing the motion for the box. Do you agree?
Yes, ma'am.
If that we accept, then the only way that we can say the acceleration of the box is being given by the frictional force, but why friction is acting in this direction? If the friction was not acting here, the possible motion for the block was to go back and hit this wall. So it is the future predicted motion. So the friction should oppose it. So the friction accelerates the block with the same acceleration in the forward direction. Okay, that picture is very essential. I don't know how much you got it right now. I told you, but when you solve different problems, you will understand the importance of this friction. Okay.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Yeah. So now what we will do is, there are two problems that are discussed. Shall we work out that, or have you worked it out already?
5.98.
Yeah, 5.7, 8, 9. 3 problems are there. Shall we take it?
Yes, ma'am. I think we have done it in our notebook, but then it will be better if we discussed.
Yeah, we'll discuss now, because like these are all some standard type of problems which can be asked. Just they will change the magnitudes of mass or angle or something.
Yes.
Okay. Oh, 1 minute. Okay. The question 5.8 first we'll take. That's actually very important. They have discussed it as a problem, but it is actually one of the formula that we will use repeatedly. Okay. We'll first ignore all the given values, like angle is 15 degree or something like 4 kg and all is given. No, 1 minute. Okay, what I will do is I'll take it as a separate heading itself. Just a minute. We'll work out that, then we'll substitute these values. Okay, that will be better. There is one word which I want you to remember. Yeah, one more. I just like what we had written here. No, we can even rewrite it. So if you want to define coefficient of kinetic friction, what you will do? It is like, I can consider Fs is the Fs max. I'll write down. What we had is, if you want to find out coefficient of static friction, what you can do? Fs max by normal reaction. Can I able to write like that? Because Fs max is equals to mu Sn.
Okay, so mu you bought this side.
I just had.
Okay.
Yeah. So now you can remember this also for the definition of mu S max. Okay. So that is coefficient of static friction can be defined as the ratio of maximum limiting friction to the normal reaction. Okay.
Mu is constant. Right?
Similar. For the given two surface.
Yes.
Okay. And mu k can even be said as Fk divided by N. Is the ratio of kinetic friction to the normal
Now,
reaction.
will it be FK
This is
or
the other
FK
way.
max?
There is nothing like Fk max. Your kinetic friction is a fixed value. That's what I initially itself told. This is constant. This is not self-adjustable. Only Fs is self-adjust. I mean, even not Fs max. Fs is self-adjustable and its maximum value is Fs max.
Oh.
Okay, so that's very important. Your Fs is adjustable, but Fk is not adjustable. Okay, kinetic friction for given to surface, it is always constant. But your Fs depends on how much is the external force that is acting. Okay?
Yes.
Got that difference?
Yes.
Yeah. So now, there are 2-3 terms we define. That is, first one is angle of repose. So what is this angle of repose, or in other words, it becomes easy to understand, angle of sliding. What is this angle of sliding or angle of repose? So let us say we have an inclined plane. Okay. Like, as this is just developed with many set of experiments. So, and even actually like with some Galileans, Galileo's contribution is also there, and he has performed many series set of experiments in inclined plane. So the discussion goes like this. So let us say there is an inclined plane. Do you imagine that you place a block over there? Okay, and initially let us say the angle was like, it was this inclination. And slowly we are increasing the inclination. Are you getting my point?
Yes, ma'am.
Like, this is the horizontal line. There was one vertical movable arm. So you're keeping on increasing it. Okay, you kept on increasing it. Initially, when it is almost like, you can imagine like it was raised from here. Does the object will slide, provided if they are friction surface? No, when it is almost parallel to when the angle of inclination is very small, does it slide?
No, ma'am.
Like, even I'll further rise, I see that it will not slide. As I keep on increasing the angle, at some point it's just to start to slide. Okay, here that just to start to slide is very important, where you see your frictional force is just balanced by the applied, just balanced by something. We'll talk about that something little later. But I think you agree, as I keep on increasing the inclination, at some point the block will start sliding.
Yes, ma'am.
Do you agree?
Yes.
So now here is something very important discussion. So whenever inclined plane comes, this should be very clear. So now, if I draw an object in the horizontal plane, where will be mg acting? It will be always acting vertically downward, correct?
Yes, ma'am.
And your normal reaction must be always perpendicular to the surface. Okay, please remember that.
Okay.
When it is on the horizontal plane. Now when I come here, okay, so where will be mg acting? Mg will be not acting something in this direction, because this is not perpendicular to the horizontal surface, right? This is not perpendicular. Do you agree? For the horizontal surface,
Yes, ma'am.
it will be acting in this direction. Okay, like this is my horizontal reference line. So this mg should be perpendicular to your horizontal reference line. Got that logic?
Yes, ma'am.
Yeah. So now, further going ahead, where should I draw my normal reaction? Normal reaction will be always perpendicular to the surfaces that are in contact. Like this is the surface which is in contact. I should draw a line which is perpendicular to that, something in this direction. Do you agree?
Yes, ma'am.
Please draw it properly. I mean, just something like this. Yeah.
Yes, ma'am.
It is perpendicular to the surface that is in contact. Like I can show here, but it becomes clumsy if I draw. So I'm showing there. Okay. So, but which surface in contact? Hope you got it. Correct?
Yes, ma'am.
So always normal reaction should be drawn perpendicular to the surface that are in contact.
Okay.
Okay. N. Now, this is our mg. Now, what we will do, like we have already learned something like resolving of vectors and all. When the vectors are acting at some general angle, what do? We usually resolve it into two perpendicular component. Correct? Two perpendicular component. So what we can do is, whenever the object is sliding an inclined plane, it is easy to assume one direction which is parallel to the surface itself.
Yes, ma'am.
Can I consider, instead of x and y axis, what we'll do? We'll choose our one axis parallel to the sliding direction itself. Okay.
Okay.
So what I can do, I'll just say this is one component. And the other axis, what I choose is something which is perpendicular, which is opposite to our normal reaction. Like perpendicular to sliding direction. Obviously, if this is parallel to this line, yeah, if I said this is parallel to the surface, then obviously this particular line must be perpendicular to the surface, right? Or just like your normal reaction is anyway perpendicular to the surface. Correct?
Yes, ma'am.
Now, the angle between the horizontal line, between these two lines is theta. Okay?
Yes, ma'am.
Now, just pay attention. I'll say this line and this particular line are perpendicular to each other. Do you agree? That is the line of action of mg.
Yes, ma'am.
Obviously, by this definition, because always mg act perpendicular to the horizontal surface. So your this particular red and this particular thing, they are perpendicular to each other.
Yes.
Do you agree? And this particular line that is sliding down and this particular line are perpendicular to each other.
Yes, ma'am.
Do you agree?
Yes.
Yeah?
Yes, ma'am.
So now the point is, the angle between two lines, I could see this angle, will be equal to the angle between their perpendiculars. That is one important relation which you get in your mathematics. So, like I could see the angle between these two lines as theta. Okay.
Okay.
Now, what is the line that is perpendicular to this horizontal reference? This one. Correct? The line direction of mg.
Yes.
Yes or no? And what is the line that is perpendicular to this inclined surface along n or something like this way? Can you see? They should be equal to theta. If the angle between two lines are theta, then the angle between their perpendicular is also going to be theta. Okay, got it? You can prove it just by using some trigonometric, the angle sum to 180 degree. That you remember, and you can prove it with a simple step. If you want, you can do it later. Try it out.
Okay.
That's a simple calculation. I think you would have done it in some of your earlier schooling. So the point is, if the angle between two lines can be seen as theta, then the angle between their perpendicular must also be theta. Okay?
And this is 0.2.
Hmm?
Nothing, ma'am.
Yeah. So now, if this is mg, what will be this component now? Can you tell me? The resolving component. Because now I got the angle as theta.
Yes.
So can I write it as mg cos theta? Yes or no?
Yes, ma'am.
And I can write this component as mg sin theta.
Fs will be mg sin.
Yeah, correct?
Yes.
So always, If you understand, that is well and good. If you like, sometime you may get confused, just directly write mg sin theta is the component along the sliding direction. Mg cos theta will be the component which is equal and opposite to your normal reaction. This is true for all inclined plane. Okay. So now, yeah, this is the basic part which we wanted to do. Now what we will do is, if I say, like, if you just think, if this angle is just slightly increased, the object will start sliding. So I am in that impending, in the verge of motion. So in that case, all the forces are just balanced, correct?
Yes.
So what we can say, all horizontal forces must be equal and all the vertical forces must be equal and opposite, correct?
Yes.
That's no, at just sliding down point or sliding down angle, at just sliding condition. Okay. So yeah, I think I didn't tell you what is this angle of repose. So your angle of repose is that angle, okay, like this particular theta, at which your object will just start to slide.
Okay.
How do you define? Like I told, we keep on increasing the angle slowly and you observe it. At some point of time, it just start to slide. Okay. So that particular angle is called as angle of repose. Okay. Any angle slightly greater than angle of repose, the block will start sliding down with the acceleration. Okay. With the acceleration. But at the angle of repose, it is just like, the block will start just sliding down with a equals to 0. Acceleration is 0, but you should give some small initial push. The block will start sliding down slowly with that uniform speed. Okay. Acceleration should be 0. Got it?
Yes, ma'am.
Yeah. So in that condition, just a sliding condition, what do we have? Yeah, there is also one force which I left it, sorry. So that is your frictional force. Where does your frictional force act? This way.
Opposite direction.
Correct?
Yes, ma'am.
I'll write Fs because it is not started to move it. Slide more, the object will start sliding, correct? So your friction is, static friction. Yes or no? Yeah?
Yes, ma'am.
Yeah. So now, in that case, what you can say, like summation over F along sliding direction should be 0, or summation over F, I'll just use the word like vertical. The vertical direction must be 0, correct? Both the conditions should satisfy. Then only the block will be at rest. Do you agree?
Yes, ma'am.
Now, what are the forces I can see? I can see like mg sin theta is this way, or Fs is this way. So at equilibrium, they should balance, correct?
Yes, ma'am.
I can say, and I'm writing vector sums, vector sum. So I can say like mg sin theta minus Fs should be equal to 0. Do you agree?
Yes, ma'am.
Or you can say your mg sin theta must be equal to Fs. This is equilibrium condition. Directly you can remember this equation. And similarly, what you will get for vertical direction, like one is acting upward, one is acting downward, you can write like n minus mg theta equals to 0, or n equals to mg cos theta, correct?
Yes, ma'am.
Yeah. So now what we will do, we know that our static friction is the ratio of Fs by n, no? So I'll say this is 1, this is 2. Divide 1 by 2. What you will get? Fs by n. But I know this is nothing but equal to mu s. Yeah. Is equals to mg sine theta divided by mg cos theta. mg cancels out. Sine theta by cos theta will give you
Tan theta.
tan theta. So this is one important formula. The coefficient of friction is equals to tan of angle of repose.
So theta 15. So tan 15 will be the answer.
Okay, you are working on that problem.
Yes, so tan.
It's like tan inverse of mu s will be equal to theta.
So tan 15 will be 0.27.
Tan 15 is 0.27. Okay,
Yes, ma'am.
understood?
Yes, ma'am.
So this is how a later in the free body diagram concept also we do like this. We first draw a neat proper, diagram where the forces acting on one particular body will be drawn explicitly. You had to draw all the forces that acts on the body, not the forces that are acted by the body. You had to draw only the forces that are acting on the body. Okay.
Okay.
Yeah. So this is one important relation. Okay. Mu s is equals to tan theta. What is theta there? It is not that some general angle. It is that angle where just sliding down, start to slide down. Okay. Tan inverse mu x equals to tan theta equals to mu s. Okay.
Yes, ma'am.
Yeah. Sometimes, there is one more angle called as angle of friction, but I'll not tell you in detail what is this. Angle of friction. Its definition is slightly different, but your angle of friction will comes out to be equal to angle of repulse. Angle of repose. So in problem, if they mention something as angle of friction, don't worry, it is also equal to angle of repose. Okay. So it is also still follows like mu is equals to tan alpha, where alpha is this angle of friction, or you can say your alpha is anyway equal to theta. Okay. So angle of friction or angle of repose, any word can be used, but their definitions are slightly different, but magnitudinally they are equal. Okay.
Yes.
Yeah. So now we'll have a look about the other problems there. So now quickly have a look about 5.7. I think you understood, no? 5.8, I think not necessary. Now you can directly calculate, no? Mu equals to tan s. That's what they are doing. Okay.
Yes, ma'am.
Yeah. So have a look about 5.7. Determine the maximum acceleration of the train in which a block lying on its floor will remain stationary, given that the coefficient of static friction between the box and the train floor is 0.15. It's a simple, straightforward question. So, like the above example, what we have discussed, no, like train and box.
Yes, ma'am.
That is helpful here. And we already assume whatever the acceleration that the block is getting, correct? Is because of friction. That's what we said, right?
Yes, ma'am.
So and force equals to m into a, that we have learnt in second law. Force is equals to m into a. So the net force on the block.
Cancelled. So okay.
Yeah. MA must be equal to your frictional force, or which is also equal to the maximum possible value you have to take, mu s into n. But mu s is by default equal to what? M into G.
Mg.
In all your horizontal position, it is just like M into G. The normal reaction is balanced by M into G. But in the inclined positions, what happens? N is equals to mg cos theta. Your normal reaction is just equal to the cos theta component of weight. Okay, mg cos theta. That you should understand.
Okay.
Then everything is given over there. So maximum acceleration is mu s into G. That you can calculate. Correct? End of the chapter. Again, they had given some points like free body, solving problems in mechanics. Page number 1.5. Sorry, 105. Some
105. Okay.
So that's what given there. So I'll tell you here itself, okay, how to draw the free body.
Okay.
Like when we do some problems, you'll get an idea. So it's not the theory to be learned, it's the problem to be practiced over there, okay. So in the 5.9, it is one good problem. Like there is some surface, okay, and there is a pulley system kind, and there is some trolley which is moving and connected with the string. The same string runs over the pulley, which is connected to a mass of 3 kg, correct? And this is of some cart is of some 20 kg,
20.
correct? And they had given like it is a friction surface. In few cases, they may say it's a frictionless. Ideally not possible. I mean, ideally possible. Practically some friction will be there. Correct?
Yes.
And
14
here, what they had given is, what is the acceleration of the block means it is very clear the object is moving, correct? So then,
Yes, sir.
and see, this is your choice, okay? Object is moving they had given. There are two possibilities. One, this will move in this direction so that the block can run over. But usually what do we notice when we allow the 3 kg to, fall, if you don't hold it, definitely it just, falls down, correct? This is how we usually see. Yeah, 3 kg falls down with some acceleration, correct? We can imagine like that. Yes or no? Yeah. What is the acceleration of the block and trolley system shown in the figure? If the coefficient of kinetic friction is 0.004, like mu k is given, kinetic friction, so 0.04. Do you agree? What is the tension in this string? You are supposed to find out the tension in this string as well. And I think I had told you a slight idea of tension, right? So where should you draw the tension? Tension, like if I look from this mass, this tighten with some string, but I am not seeing this mass is, breaking and going down, but there is a mg acting downward. So there must be some tension in this string which is opposite. Correct? So you always draw the tension away from the mass. Okay. And now if I see here, okay, so what do we see? Like, but what we are seeing is like this block is going in this way. It is just trying to move down, right? Try to pass to come near the pulley. Do you agree? The block is trying to come to the pulley. As the 3 kg goes down, this will move in this direction, correct? Yeah. Yes. But is there any external force you see? No. But somebody is pulling this. No. That means the tension in the string must be pulling it. Correct? So that's why the tension here must be in this.
Tension formula is Mg minus Ma. Huh? Tension formula Mg minus Ma.
That depends. Yeah. I mean, depending on the situation, it comes. Okay. You need to see what are all the forces they are acting. Here it is true. Okay. I'll tell you. I mean, there are few things you have to learn here. That's why I'm just, going very slow with this. See, hope you understood how I had drawn tension T here in this direction. Or it's with the usual logic. When I observe here, I should draw the tension away from the given mass. Correct? That is also fine. Or there must be someone who is pulling it. That must be the tension. Because it is going in this direction. Correct? The block is moving in this way. Okay?
Ma'am, your sound is very feeble. I can't hear.
1 minute. Can you hear me now?
Yes, ma'am.
Just a second. Yeah. Hope it is fine.
Yes,
yeah.
Ma'am.
The block is moving in this direction, no? Sorry, not the block, this cart. Correct? Do you agree?
Yes,
if the block goes in this way, your cart should come in this direction. Yes or no?
Yes.
So now that means what we can do here is, first you can consider your 3 kg as system. Okay, only this we will observe. So this is our system. So for 3 kg, what are all the forces acting? So whatever the mass you see, you represent by a point particle. Okay, so that is the first step in FBD. Are you following?
Yes, ma'am.
What is the force? What are all the forces that are acting? Like there is a weight which is acting downward, M into G. There is a tension that is acting upward. Correct?
Upward.
And also we assume that the block is accelerating downward. Correct?
Yes, ma'am.
Now, whenever there is an acceleration, what we will do? We say like F net equals to M into A. I have to write. What we have to write? F net is equals to M into A. So what are all the net forces you could see? There is one tension T, there is one mg, correct? And this is like vector. And what we had to do is consider the forces that are acting in the direction of acceleration, take it as positive. So that means mg should be taken positive, minus T will be equal to M into A. Do you agree?
Yes, ma'am.
If you understand this much, it is easy now. Okay, mg minus T. Why I am writing like that? The force along the direction of the acceleration to be taken positive, opposite to A should be taken negative. Okay, is it clear?
Yes, ma'am.
Now that is done with one case. Now coming back to our like this cart which is represented by W in the diagram. So if I consider that as system now, for W, is there any normal forces that are acting? Obviously it is there. There is some normal reaction N which is balancing mg, but this is of no use actually. Okay, your N is balancing mg, but we don't want this particular equation because it will not solve our required question. Okay, fine. Then what is happening along the horizontal direction? There is some acceleration along the horizontal direction. Can you see it? Like as it goes down, this moves horizontally. Correct? Yes. And there is a tension in this direction. And there is something like friction, kinetic friction opposite to it. Correct? Yes. So now what is the equation you will get? So one is N balances mg. I will not write it. Okay. So I am interested only horizontal equation because the object is moving along the horizontal direction. So, and my acceleration is this way. So tension to be taken positive. Do you agree? So yes, F net equals to M into A I had to write. So what do I write? T minus Fk should be equal to its mass. I'll use the notation capital M because this is of different mass into the same acceleration. Okay. In all your CBSE board level problems, yeah. So motion of the connected bodies they will tell, or for all this type of cases, usually acceleration will be common. Okay, if this is accelerating with something, this will also accelerate with the same acceleration. That is the condition for a connected body. Okay, or else then this string will not be so tight. It just comes out of the pulley. So that is like that. Okay, so to keep it string fit and straight, so both acceleration must be same. Okay. Yeah. So now further we can solve because only tension is not known to us and acceleration is not known to us. But how many equations we have? 2 equations, correct? 2 equations, 2 unknowns. It is solvable. Do you agree? According to mathematics, solving simultaneous equation means the number of unknowns must be minimum. I mean, the number of equation must be minimum equal to the number of unknowns. All other quantities we know. Correct? We can substitute. So what we will do, tension we want, no? Tension is MA into Fk. But what is Fk? But no, one more step we should go because A is also unknown to us, right? Sorry. So what we'll do, so you observe here, I will add, let me say this is equation 2 and this is equation 1. When I add them, what do I get? Tension will cancel out. Do you agree?
Yes.
When I add 1 and 2, Does the tensile cancels? Correct. So what do you get?
Yes.
Mg minus Fk
Minus.
is equals to M A, and what else is there? Plus M into A. Correct?
Yes, ma'am.
Huh. Okay, but Fk can be found out. Sorry, I thought it is not necessary. But your Fk is equals to what? Mu k into n.
And
But n equals to what? M into g. This is also necessary. Capital M into g. Sorry. Correct?
yes,
By
ma'am.
the balancing in the vertical direction, what do we get? N equals to capital Mg. So you can substitute now. Your Fk is equals to mu k into capital M into g. Capital M is how much? 20. G is 10.
20.
Mu k is 0.04. So 0.04, 20 into 10. So like with this 0, this 8 you will get, no?
8 Newton. Yes, ma'am, 8 Newton.
Huh. Where it is, had they solved in this method? Okay, they are working out explicitly, no? 8 Newton, okay? So now we can substitute here. 8, correct? And mg you can get. Just be careful, like which m and which, capital M should be taken as what? And small m should be taken as what, okay? What is m into g? Small m into g means 3 into 10, that is 30, right? 30 minus 8 equals to ma, like I can write a outside. Capital M plus small m, how much it is? 23.
Capital M is 20. 20 plus 23.
Only mass, no? That is 23. Now you will get your acceleration here. How much it is? 30 minus 8,
30
which means 27, no? Sorry, 22.
Yes, ma'am.
30 minus 8, 22 divided 23. This is around something less than 1, like 0.9 something you will get. That is your acceleration, correct?
0.95.
Fine, 0.95. Now substitute the value of A in any one of the above equation. You get tension. That's what they had done. Okay. So you know, like you can substitute in equation 1 or 2. That is of your choice. Okay. Here also you can substitute because you know the value of Fk, you know capital M, you know A. You can calculate T. Here also you can do the same because only T is unknown. Okay. So that is what your simultaneous solving. Like number of unknowns should be at least less than or equal to the number of equations we are having, or else we are unable to solve this problem. Okay. Is it clear?
Yes.
Okay. So yeah, I'll just share this first. With a rolling friction, it is just a theory is there. Okay.
Tension will be 27 something.
It is given like that. 27.1 is mentioned.
0.1. Okay.
I think you'll get it. Further things are simple calculation. Okay. Yeah, I'll just share this file. So with the rolling friction, okay, there is just some theories there. Will you just read it once on your own? Just like the friction that exists, you know, when the objects are rolling. Sliding and rolling are different. Do you agree?
Yes, ma'am.
Yeah. So just once you read through it, because that is some little theories are there. And then how can you reduce friction and all? You can just, read it once. So probably I prefer to start from that circular motion and motion of a vehicle on level road and banked road. Can you see that? That is very, very important. So I think I prefer to start from that. Is it okay?
Yes, ma'am. I understood nothing but that.
So that's why. So try to read rolling friction on your own. So like I prefer to start that circular motion concept is, that with the one full, full session will be better. That's why I don't want to take rolling motion in my next session. Okay.